Today we're going to carry on with ratios, but we're going to bring some fractions into it. So I hope that sounds all right. So what I'd like to do is pause the video and try this question here. Using this bar diagram, can you answer A, B, C, and D? Okay, the ratio of red to green is 3 to 2, whilst the ratio of green to red is 2 to 3. It's really important when you read the first bit of the ratio, it corresponds with the first number, and then the second bit will correspond with the second number, and so on if you had more than 2. The fraction of red. Oh, okay. This is a slightly newer idea. Perhaps you've seen it before though. But if we think about the fraction of red, well, when we have a fraction, we're comparing against the whole amount. So the fraction of red is actually 3/5, whilst the fraction of green is 2/5. So suppose ratio compares quantities would be a good summary. Fractions compare against the whole amount. Ratio compares quantities together. Okay, that's a little summary of the difference between ratio and fractions. Okay, onwards. So we might be asked questions like this, involving fractions and ratios. And if you're confident with the first question, I reckon you can give this a good go. So again, pause the video, see if you can answer these questions. All right, now don't forget a bar diagram can help with these sorts of questions. You might be able to do it without a bar diagram, that's fine. But if I've got 3/8, then I can split my class into 8 parts. 1, 2, 3, 4, 5, 6, 7, 8. Brilliant. And then if I've got 3/8 are boys, then how many are girls? Well, it's the unshaded part here. It's going to be 5/8. The two are going to have to equal 1 in this case. And the ratio of boys to girls, I can see from here, I'm going to compare the quantities, not with the whole amount now, but with each other, and it's going to be 3 to 5. Okay, another question. If the ratio is 5 to 7, what fraction of the class are boys? And maybe you can do away with the bar diagram now, and you can think, right, well, I got 7 boys, and how many have I got in total? 5 plus 7 is 12. That's going to be the fraction of the class. So we need to be able to go between the two. Hopefully this is all making sense. Finally, let's chuck some algebra in there. We can work generally. It's always good to try and generalize things. If we have A to B, write down an expression for the fraction of girls and the fraction of boys. Well, the fraction of girls is going to be how many there are, divided by, how many girls there are, divided by the total number. So it's actually going to be A plus B. And then the fraction of boys is going to be B over A plus B. And that's our answer. We can't simplify this. I cannot cross those A's out and cancel them. No, 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 because I'm adding the B, you can't do that. If I was going to write the fraction of girls plus the fraction of boys, just for a bit of fun, then it would be this. Just introducing algebraic fractions, I add the numerators as normal and keep the denominators the same, and I get 1 because A plus B divided by A plus B has to equal 1. The fractions must equal 1. Okay, brilliant. All right, another one. Let's throw some percentages into it. Remember, fractions, decimals, percentages, they're all they're just different ways of writing numbers. So this is no different really. It's just that once you've got your fraction, you have to convert it to a percentage. Give this a go. Okay, again, you could use a bar diagram if you want. This is going to take a while to draw a bar diagram fully, but I could just do a little brief bar diagram. I've got 7 parts that are cats, I've got 10 dogs, and I've got 8 rabbits. So the percentage of animals that are cats, well, 7 parts out of the total amount is going to be 7 plus 10 plus 8. And that is actually 7 over 25. So I've done the fraction bit. I just now need to change it into a percentage. And the easiest thing to do is get it, well, you could do a division, 7 divided by 25, get it as a decimal, and then times by 100. But actually, a good shout when you've got a fraction is to try and get it over 100 or 1,000 or 10,000. It depends. In this case, it goes over 100 by timesing both by 4. And it's going to be 28 over 100, or 28%. Okay, nice one. Now I've gone through a few. Hopefully you tried them and you're feeling confident. I want you to practice a few more from A, the A sheet that I'm gonna attach, and B as well. Give it a go. Okay, do this for, this should be done for maybe 10, 15 minutes, and then I'm going to go on with it. I'm now going to show some answers so you can check. Okay, here are the answers for part A. Hopefully you're like, yeah, right now. And part B, okay, a bit more wordy, but all the information's in there. In some cases we've got fractions and percentages. We can deal with it though. Okay, here are the answers. I'll be talking more about fractions and percentages in a minute. Okay, some of those later questions up here required you to use fractions and percentages together. So maybe I got a bit ahead of myself because I hadn't spoken about that yet. I'm going to do that now. So you might always want to, you could go back to those other ones if you didn't get onto them or if you struggled. So we've got some people sharing some money, and now somebody gets a fraction, somebody else gets a percentage, the rest goes to Jeremy. Work out the ratio of each person's share. How are we going to deal with this? Well, we need to be able to go between, we need to be able to understand percentages and fractions. Now, I'm going to do this question two different ways. In method one, I'm going to change everything to percentages. So we're going to get Mohammed, right, 2/5. You could write that as 4 over 10, which is 40 over 100, which is 40%. So Mo gets 40%. You could, of course, do 2 divided by 5 is 0.4, times that by 100 and get 40% that way. Lisa gets 28%, and therefore Jeremy is going to get, we're going to add them together, 68. It's going to be 100 minus 68. Jeremy's going to get 32%. And we're basically there. We can write down the ratio. It's going to be 40 to 28 to 32. It doesn't say to simplify it, but it's basically standard practice in this sort of question to simplify it. So I can see that 4 goes into every single one. So I'm going to divide everything through by 4. I'm going to get 10 to 7 to 8. And there we go. That's the ratio. I think that's a good method. Hopefully you're happy with that. Okay, method 2. Let's deal with fractions. So this time we've got Mohammed with 2/5. We've got Lisa with 28%. We're going to have to change that to a fraction. It's going to be 28 over 100. And at this point, you probably think, okay, keep 100 as the denominator. You could change it. You could simplify that 28 over 100. You could make it 14 over 50. Yeah, let's do that. There's different ways of doing this question, actually. I've changed my mind. 14 over 50. So I can see that Mohammed is going to be 20 over 50. Because I've just multiplied through by 10. And then if I want Jeremy's going to be the rest. Well, this is 34 over 50. So I'm going to need to do 1 minus 34 over 50. Remember, this is 50 over 50, and Jeremy's going to be 16 over 50. Okay, so I'm going to put them in a ratio. It's got to be said at this point, I think this method just overcomplicates it. I think getting a percentage is much easier, but it's still worth talking about. Okay, we can basically time through by 50 and get rid of those, and then we could divide through by 2 and we'd get the same answer. All right, one more. Welcome back overlapping ratios. Hello, we got men to women 3 to 4, and ratio, that should say, of women to children is 3 to 5. What fraction of the people in the restaurants are women? Okay, we know, well, pause the video, have a go at this one. Right, we know how to deal with this. Men to women is 3 to 4. Women to children is 3 to 5. We're trying to get it so these numbers are the same because then we can combine it all together. So I'm going to times this through by 3 and this through by 4 because that will make it 12 and 12. Okay, that is the lowest common multiple. So I'm going to get 9 to 12 and I'm going to get 12 to 20. Therefore, men to women to children is going to be 9 to 12 to 20, which I can simplify to 3 to 4. No, I can't simplify that. What am I talking about? There's no common factor. Okay, ignore that. Right. So we've got our ratio. What fraction are women? Well, we've got 12 parts women. And then we divide by the total number of parts, 41. Okay, that was just 9 plus 12 plus 20. And there we have it. Brilliant. So we can now deal, some of these earlier problems that have come in and simplifying ratio, all these skills are coming back in, overlapping ratios. The main point of today's lesson is just to reinforce the idea of fractions and ratio and how it's different, but how it's linked together. So now I want you to try some more questions. We've got part C here and part D as well. Go for it. Okay, just going to reveal some of the answers. Answers to part C. Some algebraic ones down here. And to part D with these overlapping ratios. Okay, all good, I hope.